Thank you very much, Tal. Welcome to the webinar of the Bell Shape for external thread milling. We developed this type of tool holder, the Bell Shape, for external application and for dedicated component. We are speaking about the common rail. What is the common rail? The common rail is component of fuel injection system in diesel engine. And of course, when we speak about automotive industry, diesel engine, we are speaking about mass production. And when we speak about mass production, we speak about machining time should be as less as possible because every second is important. In the past, we offered to the customer for this type of component 3 solutions. TM standard with 1 insert, MITM with 4 flute, and the TM solid. The difference between them is the machining time. TM standard with 1 insert is relatively long machining time. Then we offer the MITM with 4 flute, and we can cut dramatically the machining time. But it was not good enough for the customer because, again, every second is important. So we offer the TM solid, and also we reduce the machining time. The customer was very happy with this solution, but he said, I need less machining time. I want to reduce my cost production. And then we came with the idea of the bell shape. Now, the idea of the bell shape, the tool holder is around the component. So the movement of the tool is very short. Beside this, this is a multi-flute tool holder. In this case, you have 4 inserts, and this is for fast feed. Let's see it in the diagram. Let's see first the MITM. When we use the MITM, we have to rotate the tool around the major diameter. Okay, so the movement is relatively long because this is the diameter of the component. Let's see it in action. This is the movement of the MITM exactly around the diameter of the thread. It's relatively long. When we speak about the bell shape, the movement is around a very small diameter because the tool is around the component. So this is the movement. It's very short. You see the big difference between them. Let's see it in action on a real machine. First, we see the MITM. This is the MITM with 4 flute, and you see the external thread one after another. Pay attention to the gap between the threads. So this is the movement of the tool around the diameter of the thread, exactly. And let's see what is the machining time. Machining time is 14 seconds. It's good, but not good enough. Let's see the TM solid. TM solid is faster. You see the movement is faster because the tool is smaller. And let's see what the difference in the machining time, 12 seconds, 2 seconds less. Now let's see the bell shape. The tool holder, now pay attention to the movement. Very short movement. So the machining time also very short. Now let's see it with coolant water to evacuate the chips. And pay attention to the gap between the thread, very small. And you have to design the bell-shaped tool holder exactly according to this gap. It's very limited. Okay? Now you get the impression for the movement is very, very fast. So it's only 3 seconds. This is a big difference between MITM, TM solid helical, and the bell shape. 14, 12, and only 3 seconds. What are the other features and benefits of this bell-shaped system? Another advantage is the structure of the tool holder. This is the second version of this bell-shaped system. The first version, we call it the old system, was tool holder with open structure on the bottom of the tool holder. So what happened when you machine with the bell shape, the old style, the tool movement is very fast, the forces are very high, and the component push a little bit the insert. So what you get is a conical effect. So when you measure with the gauges, go, not go, you see that the thread is not okay, and you have to replace the insert. Even if you look on the insert, it looks very good. When you use the new bell shape, the structure on the bottom is closed. You see the blue area. We closed the tool holder on the bottom. So now the insert has no possibility to move a little bit. It's all the time parallel. So the thread is all the time parallel, not conical. And therefore also the tool life of the insert is higher. You can use the insert for more and more components. Now, because the structure of the tool holder is closed on the bottom, it's a problem for the chip evacuation. Therefore, we designed the tool with 3 outlets for each insert. So in total, on the tool holder, you have 12 outlets. This is a massive coolant which push all the chips outside of the material, of the area. And when you see the component after machining, the component is very clean, no chips around, and the surface finish is very, very high. Now about the insert, it's a multi-flute tool holder, so we have 4 inserts, 3 of them with multi-tooth to cut the thread, and the additional one also with multi-tooth, and also a deburring option at the end of the insert. Because when we make the thread on the top of the insert, sometimes we have a burr. So in order to remove the burr on the same movement, we make this type of insert. So 3 insert, multi-tooth for threading, and 1 insert threading and also deburring. All the insert, except of the insert with the deburring option, is double side, so you can increase the tool life by 100%. And the clamping for the insert is very easy because we have a hole in the tool holder where you can very easily put the screwdriver and fasten the screws. Again, because we are speaking about fast movement, high forces, we have to take care of the clamping system. It should be very, very rigid. That's why we add at the back side of the insert the dovetail, so now the clamping is very, very good. The surface finish, because of the clamping system and because of the unique design of the insert, is very, very high, and the customer was very happy with this type of tool holder. Let's see the movie that we make for the Bell Shape. In the video, we cut the components so you can look inside. In this case, you see the insert with the deburring option. This is the tool holder, the closed shape of the tool holder, 4 inserts inside. These are the 3 inserts with multi-tooth for threading. You see the fastening with the screw is very easy. And the additional one, which is an option, you don't have to use it. This is the insert with the deburring option. And the closed structure of the tool holder. This is the dovetail on the back side, which gives you a very rigid clamping. And this is the operation. You will see again the movement is very short. You see the chips, and now we use it with coolant, so all the chips just flow away. And the result is very clean area and very high surface finish. So you see again and again the action is very, very short, and you see the gap between the thread, which is very critical for the tool design. So this is the bell shape for the common rail. This is the tool holder, multi-flute tool holder. Our standard program is based on 1 holder, which is suitable for 2 applications, M14 by 1.5, thread length 11.5, and M16 for the same pitch and the same length, because this is what we have on the common rail. And we have 2 types of insert. The first one, multi-tooth insert, and the second one, multi-tooth insert with option for deburring. Again, option, it's an option. You can use 4 inserts, same style, multi-tooth, and not deburring. But if you need the deburring, you can add the 4 insert. Now, when we designed the bell shape, it was dedicated for the common rail. But very soon we found that there are more and more industries, mass production, that you can use this type of tool holder. And in this case, I'm talking about the valves and fitting industry. This is a mass production industry with a lot of external thread, and the bell shape is a big advantage for this type of component. This is a good example for one of our biggest customers for valve and fittings. He used to produce the fitting on a multi-spindle machine except of the threading. The threading he made on another machine, on a rolling machine. So actually, he make all the operation on the multi-spindle machine, take the component to another machine, and make the thread. Of course, you need another machine for rolling, which is very expensive, and you need additional time to make the thread. We offer this customer, please use our Bell Shape system on the same multi-spindle machine, so he can complete the component with the thread on the same machine. He accepted our idea, we made a test, and he immediately was very happy with this solution because he see the big advantage. He complete all the component in one machine, and he save a lot of machining time. And cost production, of course, according to that. So this is the Bell Shape. Keep in mind, it's not only for the common rail. Thank you very much. I hope you enjoyed this short webinar, and I hope you find more and more application for this type of tool of Bell Shape. Thank you very much.
Thank you very much, Ami, and stay tuned for future webinars by Vargus.